Okay, so today we are going to discuss about HBASE. HBASE is one of a NoSQL database in Hadoop that we have. It's very important, and we will understand like how actually HBASE helps in a real-time implementation also. Before we can start, let's understand what is NoSQL. So I'm going today, most of the things are not practical. Lot of theories are going to be discussed. So I'll give lot of break intermediate, because theories are something which really needs basic concept in getting and absorbing the things. So let's start with NoSQL. What is, when I say NoSQL, what things comes into the mind? Is it only the SQL means what? What do you mean a SQL? SQL is a structured query language. Okay, the query language. It's a kind of language where you will write a query on a structured database to get the result. Right? This is what the SQL means. But when I say NoSQL, it doesn't mean like it's only talk about not only SQL. It's a lot of things are involved. When I say NoSQL, people think okay, it's a query language or something on an unstructured data. But there are a lot of things involved. So SQL means it's a query language and writing a query on a structured data. And NoSQL means doing operation for structured, semi-structured and unstructured data as well. Okay, so it is a database software which supports performing CRUD operation. We'll understand what does it mean using SQL queries as using other way. There are some NoSQL database which also accept SQL syntax, which might not be very same what we write, but it might be database dependent. Okay, so what all I'm trying to say, that there are various NoSQL database which looks similar to SQL, but it doesn't actually a SQL. We write the SQL syntax to make the things easy, but in the background it perform some operation on some unstructured data. How it is happening? 1 minute. Yeah. So how it is happening, we'll understand this. So let's have an example. What are the NoSQL database that we have? One is Cassandra, HBASE that we are going to read, MongoDB, one of the very famous and very usable, Couchbase, Neo4j, React. So these are the NoSQL database, very commonly used database that we have in the market. And let's understand the characteristics of a NoSQL database, what it do, and actually what are the things involved. Is it only talking about a query language on an unstructured format or what? Okay, so let's understand deeply what NoSQL database is all about. Schema-less. What is the meaning of schema? Can somebody tell me what is the meaning of schema? Any idea? So yeah, correct. I mean, in a very simple language, I can say schema is a nothing, but it's a definition of a table. When I say definition, what your table is all about. What your table is all about. Like a table having 5 columns. One column is of string type, one column is of number type, one column is of char array type. So char and string are same, date type. So there are various, like you are defining your table. That is the definition of a table is nothing but a schema. But NoSQL is something which is a schema less. There is no definition for the table. So with NoSQL you can have a table where one row has 2 columns, where a second row has 20 columns, third row has 1 million columns as well. Is it possible in SQL? No, it's not possible in SQL. Okay, it's not possible in SQL. What SQL say? SQL say, like, for each row the number of column should be same, right? But NoSQL is giving the flexibility to have this, and such kind of structure is called as a sparse matrix, right? That sparse matrix. You know what is sparse matrix? See, this is your row 1, okay? This is your row 2, this is your row 3. So row 1 having how many columns? 1, 2, 3, 4. Okay, sparse matrix is the one, that one, correct? So that what is the uses of that, I'll tell you. Row 2 is having, see, the number of columns is see how it gets changed, different. Then row 3 is having so you, if you can notice the number of columns in each row is different, and this is what can be achieved through NoSQL. Now the next question, why we want this structure? What is the uses of this structure? We can have the same number of column. That I'll tell you in just upcoming discussion. I'm going to tell why we have this kind of structure and what is the uses of this structure. It's a distributed. One of the most important things is it's a distributed. When I say distributed, it is giving the flexibility to have a seamless storage capacity, right? When you work on a SQL in your table, when you work on SQL, there's a limitation, right? That's a vertical scaling. I have discussed in my videos also. That's kind of vertical scaling, that you need to scale your system and you need to invest a lot on a single system. Okay, to have a to perform the SQL related operation efficiently, right? That in a single system you need to upgrade it, right? 1 TB hard disk or 2 TB hard disk, but there will be some limitation after installation. RAM addition also, after adding some capacity of RAM, it will say, okay, don't add beyond this, and that would be the capacity. That would be the capacity limitations you have. But when you have distributed, you can add n number of nodes to a cluster and increase the capacity, storage capacity, as well as the RAM capacity, which will eventually increase the performance of your cluster. So what I can say, in NoSQL database work on a distributed mode. So most of the NoSQL database are distributed based on a horizontal scaling. I have discussed this in my video, what is horizontal scaling and vertical scaling. Data are replicated and stored so that in case of a node failure, still the data will not be lost. HBASE works on top of Hadoop, so no worries about the data failure. I have discussed this in my video about the replication. HBASE is all about running on the top of Hadoop. So there is a replication factor involved. So when there is a replication factor involved, in case of node failure, you can get your data, right? Also, it's a distributed, so it is adding an advantage to have a seamless storage capacity, right? So that is the use, that's the benefit of having distributed. Now, non-relational, relational and a non-relational. What is the meaning of both? Relational is what? When the two table, this is your EMP table and this is your DEPT table, okay? This is your EMP table, this is a DEPT table, okay? EMP is having some key. EMP is having some key. Okay, EMP table contains department number. Department table also contains department number, and since the same column is department number, so we can say these two tables are related to each other. These tables are related to each other on the basis of department number. Okay, so this is a kind of some relations. This is a kind of relation between two tables, right? This is a kind of some relation between two tables. So that is the meaning of relation. When I say non-relational, means what? It's nothing like a relation between the two tables. There would not be any primary key or foreign key constraint among two tables. I hope primary key and foreign key is aware little bit. What is primary key and what is foreign key? So, okay, good. They don't support join. There is no need of performing any join operation between these two tables. Why? Why we are not in need of, see, just note my question, like why we need this type of structure? Why we are not in need of having join? I will tell you in upcoming discussion. Just make a note of it. Why we are not in need of having join? Because join is one of the very important thing for fetching the data, right? So why so? And why this structure? I will tell you. They cannot be normalized. What is the meaning of normalized? What is the meaning of normalization? Will tell you. Just give me 5 minutes. In upcoming discussion, I'm going to tell about everything, and then that will really they'll give you a good concept like why we are in need of this, not join, and what is a use of normalization and why we are not using it. In short, I can tell normalization is a way of breaking a table record, table data in multiple tables. Okay, multiple tables. That you have a table. Normalization say you have a table of having 100 columns. But what normalization say? No, don't create a table of 100 column. Instead, create a 10 table having 10 column each. That is what normalization speaks, right? To break a table into multiple tables. Next thing, you will have to duplicate the data and store it on every tables. Okay, you will have to duplicate the data and store it on every tables. What does it mean? Just the same the concept of the replication factor that we have, right? Same the concept of the replication factor I have. I'll discuss these things. So what is just overall in a high level what we learn? It's a schema-less, no definition. It's a distributed, fine. It's a non-relational, no relation between the two tables. And next one is consistency, eventual consistency. What does it mean? What is a consistency? In RDBMS, if we insert the data in the database, it immediately gets persisted in the database. Means, suppose this client is nothing but your suppose you are using Oracle, so it's your SQL developer UI. It's your SQL developer UI, and this RDBMS is a storage where your data and everything is getting stored. So the moment when you will perform insert, update and delete operation, it will immediately make changes in RDBMS. Now the next question will come in your mind, how come it make immediate changes in RDBMS? Because for changes we do commit, right? We do commit and then only our changes get stored permanently. That is fine. But for temporary storage also, it uses this RDBMS only. Okay, for temporary storage also, it quickly make changes in for temporary storage also, it perform everything in this storage only. It doesn't have any intermediate storage in between the client and the RDBMS. So overall we can say, we insert the data in the database, it immediately get persisted in the database. Means whatever the operation you are doing on a data, it's immediately getting reflected in the RDBMS. But in case of distributed NoSQL database, you will see a cache where the data modification will be done initially, and when we freeze the changes, then it will update the final changes to all the nodes where data is present. What does it mean? Similarly, you have this client. This client is nothing but a HBASE shell. HBASE shell means like we have pig shell, we have HBASE shell as well. So through the HBASE shell, suppose you are performing some operation on a data. So what it will do, it won't directly perform the operation on these nodes directly. No, what it maintain a cache in between them. It maintain a cache storage where it performs the data, where it performs the operation. As if you have gone through my video, in the video I have clearly explained and said that in Hadoop we cannot perform update operation. We cannot perform update operation. But HBASE runs on top of Hadoop. HBASE runs on top of Hadoop. So when it runs on top of Hadoop, it maintains some cache storage where it actually do the operation and then return back the updated changes to the HDFS. Okay, so that is what the uses of cache. So suppose if you want to perform some update operation on any of these data, what it will do, it will fetch the data in the cache, it will update it, and again it will store it back to the HDFS. So it uses the cache. Then the ACID property in the RDBMS is the famous ACID property. ACID property is atomicity, consistency, isolation and durability. Okay, it's like very common in engineering time also we perform that data should be consistent. Okay, atomicity means like either it has to be 0 or 1, means either complete or not complete. So such kind of promises from RDBMS we have. So in all RDBMS, ACID property is guaranteed. We perform every non-select operation transaction. Few non-SQL database 20% support ACID, whereas most does not. Okay, so 20% only support the ACID property, but 80% doesn't support the ACID property. What is there? You can go to this link to understand in detail what is the ACID property is all about. Assume that we have three operations like we need to perform like insert, update, delete. Okay, so if you are performing these operations, and we are going to perform such operation, this is nothing but called as a transaction. Okay, that's what I said right now. Atomicity means what? That if you perform a transaction, it either should be successful or fail. It cannot be like, okay, it's an intermediate, it performed half, and that is not the atomicity that we know. Atomicity means atomic means we cannot divide it further. We cannot divide it further. So when I say we cannot divide it further, so transaction should be atomic. It means like it either should be complete or it should be fail. Okay. Geographically distributed, as I said before also, that it's a distributed mode. So the actual like one storage is in India, other storage can be in the United States or in other countries also. So it's a geographically distributed. It cannot be on the same system on a single node. It's not possible. And the last that most of the NoSQL database are open source. That is free and easy to use as well. So we just have an overview. I have not discussed anything in much detail. I'm going to discuss it, but just an overview on NoSQL, that it is a schema-less, it's a distributed, it's a non-relational, it's having eventual consistency, some few database supports ACID property, few doesn't. What is the meaning of atomicity? It's geographically distributed and it's completely open source. Okay, so we have just gone through the few properties of a NoSQL database, and then we'll understand the categories, like what are the categories we have in a NoSQL. So the categories are key value. NoSQL database can be of key value type, is of documented oriented, is of column family, is of graph database. Okay, key value is nothing but the data will be stored in a format of key and the value. I'll tell you in just a 5-minute upcoming session. I'm going to discuss this. What is this key value? Document oriented means you are going to store and everything is in document, is like in JSON format or in XML format, and a key will be associated with each document. So it's a document oriented, like we have MongoDB and Couchbase. Column family, it's not column, it's talking about column family. I'll tell what is the meaning of column family, but just understand for as of now that column family data is as a category, and HBASE and Cassandra comes in this column family category. Graph database, like which deals with a graphical representation and storing a graph value, we use Neo4j databases. So these are the NoSQL database in a categorized format I'm showing you. Now next thing is aggregate orientation. What is the meaning of aggregate orientation? Now you will get the answer of these questions, that why we want this, why we are doing this. Okay, so 1 minute. I think this is that only. Yeah, so I'm going to discuss one concept. Okay, so what's the concept I'm talking about now? In the late 1980s or something like 90s, we at that time we were using floppy. So floppy hardly the capacity of floppies were that time were like 1.44 MB, which is really a big amount of data at that time. Okay, and 1.44 MB. So we were and it's a really very big storage. Like okay, the capacity is 1.44 MB. So at that time we were really running for storage. Likewise, we don't have today, like we have a lot of storage and we are using and everything, but at that time we were really in need of like, okay, how to store anything, and we don't have that much of space. So storage is one of the very serious thing that people used to consider before designing or developing anything. So always the first priority for them usually were to avoid any memory storage. And that's why if you have in your engineering time also, in a book, a lot of places you can read like, okay, why we are avoiding this? No, we need to avoid any memory wastage. To avoid any memory wastage, let me correct it, right? This is one of the important topic that this one of the reason that we usually learn, and for everything we say, okay, to avoid any memory wastage. So that was really a very serious issue at that time in the late 80s 90s. It was really very serious issue, like, okay, memory is one of the important thing that we need to consider, right? So for anything we usually say memory is one of the key factor, we need to consider it. But now, can someone tell me that is it still the memory is a serious issue in today's world? In today's world, where we have a nano chip which usually contain 100 GB of storage capacity, right? So in today's world, the storage is really not an issue. Memory, if there is a memory wastage, that is fine. Nobody is bothering about, okay, the memory concern is there. People are bothering about the performance. Okay, so in today people are looking for better performance instead of avoiding memory storage, memory wastage. So their priority got changed with time. Now their priority is to have a better performance. So in order to achieve this, what concept came? Okay, now again I'm going back to the first point. To avoid any memory wastage, let me create one more image. To avoid any memory wastage. So that's why, how and why, and in order to avoid that, in order to avoid memory wastage, concept of normalization came into the picture. Okay, why? How normalization help in avoiding any sort of memory wastage? It can be asked, like, why, how? So suppose you are not performing any kind of normalization. You are not performing any kind of normalization, and this is your table. Okay, and in this table, the number of columns is 100. Number of column is 100. So if I say that number of column is 100 in a single table, there can be a possibility. And you know why we do normalization? To avoid any. Okay, let me say in this way, that number of columns is 100. So there is a possibility to have as many as null fields, right? There can be a possibility, right? Because it's really very impossible that for a single row the 100 columns data will be filled up. Okay, there can be a possibility to have a redundant data. The second factor, there can be a possibility to have a redundant data. So first thing, lot of null values, which is nothing but a memory wastage. Second factor, redundant data, which is again a memory wastage, right? So that's why normalization was a kind of savior for us, because both of these factors were really responsible for wastage of our memory. Okay, so we consider these two, lot of null values to avoid the null values and to avoid the redundancy of a data. What the idea proposed? The idea was to have a 10 table having 10 columns each. This will avoid redundancy. Also, the null values also, because what happened, because whatever the limited thing only we will have. So when we really want to add two date table, then we perform the join operation and we'll get the result. Okay. So when I have 10 table of 10 column, then what we need to do? The next thing, we have to perform join operation. So when I say join, again performance got impacted, but performance was really not our concern. Our concern was to save memory in late 90s time, right? So then we perform join to get our result. Okay, but the things got changed here. We really don't bother about the memory wastage. If there is a memory wastage, let it be. If few fields will be null, that is fine. That's not an issue. If there are some redundant data, that is fine. That's not an issue. What it will take? Hardly it will take 1 GB, 2 GB, 5 GB. That is fine. We are talking petabyte, zettabyte, yettabyte these days. So this doesn't matter. We are not in 1.44 MB. Okay. So it just avoided the concept of normalization itself. It just avoided the concept of normalization itself. So earlier we used to have a 10 table, 10 columns. Now things got, the thing which was our problem statement is now our desire. Now people are saying to have a one table only that can consist of thousands of columns. And if a table having thousands of columns, then there is no need of performing join operation. And when there is a no join operation, it would be a faster retrieval of a data. That's why there's no join operation. So that's why it avoids join. Okay. It is having a different number of column each row. What it helps? It helps in avoiding any null values also. See, that problem is also solved. That okay, I will take as much as I can, but in SQL database you cannot have this. Okay. Okay, so am I clear up to this much? Any question? Okay, good. So it's talking about the same thing. The aggregate orientation. In case of RDBMS, you have a two table like employee and department, and when you want to perform the result, you need to perform some join operation, and that is called aggregation, right? When we do join, that is nothing but an aggregation. In case of NoSQL, we would be storing the data of these two tables together, right? We are not storing it in a multiple table that we perform the join operation. Everything will be in the same table. There's a no normalization, but the operations are faster as compared to joins. This is called aggregation oriented database. So NoSQL is also a aggregation oriented. Okay. So all the below NoSQL types support aggregation orientation. The key value database type also, document oriented also, column family also. All these supports the aggregation oriented aggregation orientation. Okay. So what is the benefit? I have discussed what is the benefit. Just go through it. Now understand what are the NoSQL database implementations. The key value database. How the key value database? Anybody is having idea of hash map? What is hash map? Hash map is a collection in Java what is collection? Collection is a Java framework which provides a mechanism to store our data in various format, right? In various formats. So hash map is one of our collections in Java where we store a data in a key value format, okay, where is a key and a value, right? So key could be unique data like row ID and employee ID. Value can be anything, which is nothing but a binary format. What is the mechanism involved in it? Table is called as a bucket and each rows are called document. 1 minute. So what I'm saying, like where we can use key value oriented database, when you have to deal with the data like preferences, credit card information, just go through this, just read out and you will understand why we use, where we cannot use. Then do not use key value oriented database when you have to deal with the transactions or data with the relations with other tables, or like where we have a transaction, we cannot use a key value pair, and relational, we cannot use that. Okay, where you need where you are in need of querying on the basis of conditions like salary greater than 5,000, something like that. So we won't do that, okay, because the data is stored in this. Okay, document databases. What is the document database means? What is the document database means? Document database means where the value key, there is also key value, but key are unique ID and value is your whole document, which can be either JSON, XML, BSON document, which can be easily queried. The document can have map collection, etc. Document can be nested. Okay, so this is a document oriented database. This is a document oriented database. You just go through this. It's like where we use, what is the uses of that. Just an overview. I have written everything. Then now our concern, our main focus is understanding the column family database, because HBASE is one of our column family database that we have. Okay. So see, column family database, one is a Cassandra. See, I'm just talking about Cassandra and HBASE because Cassandra and HBASE a kind of competition with each other. They are having some sort of competition, right? So that's why, and they are really very similar to each other also. So that's why I'm differentiating that Cassandra is, they don't have a master node concept that we have in Hadoop. In Hadoop we have a master and a slave node. Okay, like in the same pattern is getting followed by HBASE. But in Cassandra, they don't have a master node concept. If any node fails, still the database work. How? They follow a ring topology. And how the ring topology looks like? It looks like this. Okay, where your nodes is like this: node 1, node 2, node 3, node 4, node 5, node 6, and all are connected as in a ring. All are connected as in a ring. But as we have learned before also, HBASE uses master node concept. The slave and master, where you have a replication factor, where data is replicated. There also we handle node failure and everything, and how it's storage and everything. The concept wise, everything is same. That is what I have discussed before in a videos. Okay, so where you can use these type of database, the column family oriented. Now I will also tell what is the actual meaning of column family. What is column family means? I will tell you when I'll discuss in detail the HBASE. Okay. So so where we can use it, if you want to have event logging means like if you want to store logs for each event, for each operation you want to store a log, then you will use such kind of database. CMS is a content management system where you are managing the content, like in the web page there are a lot of HTML related contents and from a different sources. Then we will have we can use HBASE. I'll show it by diagram that how we are using it. Expiring uses, like one of the benefit of having HBASE is like you can set an interval on a data, right? That suppose if you have a data, okay, and you set an interval, okay, time interval, that okay, this data is going to expire in 60 days. So what happened? So what happened? That data will automatically be removed or deleted from the database. So I can give one small scenario. Like suppose a job posting that company said to Naukri.com that I have a job posting and that will be valid for 30 days. So please do this. So what happened, like internally for that particular job posting, the expiry date would set be as 30 days, and after 30 days that data itself will be removed from the list. So in the list of having in that list of having list of all the job, you won't be able to see that requirement. Okay, so that is the one of the uses of having expiry uses. So we can use this in a column family based database. Okay, where we cannot use, like it doesn't support ACID property, so don't expect to having a ACID property like we have RDBMS. So when there is a requirement to achieve ACID property like atomicity, consistency, isolation and durability, you need to have a RDBMS. I'll show it in diagram. Aggregate function you cannot see. Aggregate function is one of are those operations that really impact the performance. Like it's not a very easy thing. It actually work on all the data set, average and sum. So it usually take a lot of time. So we cannot use the aggregate functions. Where we can use, but it's not ideal to have that. Then where is the concept of dynamic query? What is the meaning of dynamic query? Dynamic query is something is like suppose you have written a program in SQL, and in the SQL program you are generating your query dynamically on the basis of some input and value at every 5 seconds or 10 seconds. So different queries is getting generated, and then in order to fetch the data. So that is really not ideal to if you have a multiple queries through program dynamically it is getting generated. So in that situation we cannot use this column family. Also you can use if the schema may change, means if a place where the table schema is keep on changing, you can use HBASE there. Okay, so let me tell like the terminology that we have in HBASE. I'm telling about the column family for so many times. What is the meaning of column family? What is the meaning of column family? The name suggests, we are not saying, the name is saying group of columns, right? Column family having some sort of relation, isn't it? Column family means group of columns having some sort of relations. No, it's not clear. Clear it. What it means, right? You can say like that. Suppose if you have you are a SQL developer, you are creating a table. You're creating a table, and I say create a table of a customer Aadhaar card user, the Aadhaar card users data schema I'll ask you to create. What you will do in that, you will say, okay, I have to suppose for an address only, just for an address, what are the things you need? Address line 1, right? Then street, then city, then zip code. Let me write this. What are the things there? Address line 1, city, then zip code, then lot of things, right? I'm just telling few only. Any landmark, anything is fine, right? Anything is fine. Anything is fine. So we have these many things: address line 1, city, zip code, landmark. Okay. So how many columns have got created? 1, 2, 3, 4. Right. we have four columns got created. Now the next thing, what column family is saying? Column family say, instead of creating these many columns, why can't we have a single column? Why can't we have a single column for these four? And we will say that column as address. Please note this concept, because when somebody really interested, interviewer really interested in understanding your basic concept, then if you will use these kind of example, they will really impressed. Because I have noticed lot of time, like when somebody asks you any question, and instead of saying definitions, you give some scenario and explain, the people sitting in front of you will be highly impressed from you. Okay, so this is the address, and this address consists of line 1, city, zip code, and landmark. So instead of having these multiple columns, we just talk about column family here, right? So in a single column family, you can have multiple records. So what I was telling about column family, group of columns having some sort of relation, can have multiple value, obviously, because it is consist of many columns, so can have multiple values. Earlier we usually have only one value in a single column. Right now we have a column family concept. So think like that. This is one column family. Second column family can be a name. Can someone tell me? I just want to understand what are the things can come inside the name. Okay, name is a column family. How? What are the things can come inside the name? Tell me. And if it is SQL, then how many columns you will create for this name only? Tell me quickly, please, because this will really help understanding what are the things you are understanding in a good correct way or not. What are the things involved in a name? When I say name, and if you are a SQL developer, then what are the things you will add? First name, second name, last name. Very good. F name, comma, L name, comma, middle name is also fine, right? So how many columns as of now? 1, 2, 3, 4, 5, 6, 7. But now when I say column family, it's only 2. And when I say combine these two, then your address and name, and this entire set is called a table. Can I say it is HBASE table? Yes, you can. HBASE table. Okay, is it clear? Any questions? Any question from anyone? No questions? Okay, fine. So I'm just giving one just a scenario of polyglot persistence. What does it mean? Like, suppose if you have how many different type of database that we can really use in order to achieve a single field. Like we have an e-commerce platform. So what are the things we can have in e-commerce platform? Shopping cart and session data, inventory and item price, customer social graph, completed orders, and for each we have multiple things like key value stored technique we want for shopping cart and session data. For orders we need a document store. For inventory and item price we need RDBMS. For customer social graph and everything we need a graph store technique. So I'm not saying that HBASE is sufficient of doing any different thing, but HBASE can handle a single scenario, a single test case, a scenario where your performance will be highly optimized. So we can have a multiple different database, use different types of database used in a single platform. Okay, so just let's take a break, and then we can discuss more in detail about the introduction to HBASE. Okay. Okay, so can we take a break? 10 minutes or 15 minutes? 10 or 15? Tell me. Okay. Okay. Let's start at 10:50. Okay. Okay, to get the data. Okay, now I'm going to explain one of the very basic concept, and then we can call out a day. So the concept is row oriented versus column oriented database, and what it really means. Okay. Okay, let me first create a diagram, then I can explain. Let me create a new one. Okay. Okay, guys. First, read out what are the things it is saying. RDBMS. This is a purchase table that we have. This is a purchase table. Okay. So in a purchase table, how many columns are there? Customer name, product, and the amount. I'm saying again, customer name, product, and amount. Okay. Here, the data is stored sequentially based on row. Based on row wise data is getting stored. See, row 2, row 3. Okay. In row 1, what are the things you have? Prashad TV 1000, right? Prashad TV 1000. Okay. And what are these? These are the memory storage unit. If you have learned very basic C, usually C trainer, how they teach is like, suppose you have, most of the time they teach like this only. When they teach array, how they teach arrays, how the memory getting stored in a C. Suppose this is your array, okay, and this is like a blocks you have in array. These are blocks that you have in array, and then what? Then they say like, okay, this is suppose this is, if it is an integer data type and it is like 10, then the next address will be 102, right? I say 10, then the next address will be 102, then next address will be 103, then next address will be not 103. I'm sorry, it should be 102, then 104, right? And then 106. So in this way, like 2 bytes it was taking, and that's in the C programming. It's a kind of primary thing for us. So when we're teaching storing the data like this in this pattern. So in the same way, I'm trying to explain that. 1 minute. In the same way, I'm trying to explain that this data, like the first Prashad TV 1000, this data is getting stored like in the row oriented basis, like your row 1 and this, and the memory is like 100, 102, 104. Okay. Now second data, row 2, Suman clock 200, then Suman clock 200, and then the memory is like 120, 122, 124. Then the third is Ravi PC 1000, then it will be like Ravi PC 1000, and the data is like 130, 132, 134. Okay. So this is how row wise data is getting stored. Okay. Row wise data is getting stored. See, so now we understand how the column wise data is getting stored. Okay. So row wise, we understood. Now column wise, how many columns we have? We have 3 columns: customer name, product, and amount. We have 3 columns: customer name, product, and amount. So, so now, what are the customer name that we have available? So we have customer name like Prasad, Suman, Ravi. Okay. So see, Prasad, Suman, Ravi, and the date, and now the memory will be 130 to 130, 132, 134. Right? It's now these memories are adjacent to each other. Now these memories are adjacent to each other. Now second, now second thing. Second thing is your TV clock PC. So it comes like TV clock PC. Third thing is amount. Amount is your like 1,000, 200, and 1,000. And if you can notice, it is all redirecting to a same kind of memory because it belongs to a same row. See, 130, 130, 130. So it's a kind of first the memory saving technique. Second, it helps in compression. It helps in compression when you compress data. And now how the column oriented database helps in compression, your next question would be like this only. That why? I mean, how you can say like, okay, this helped me in compressing the data. You can say, right? Now, how I can say like that? Now suppose you have a customer name. Customer name. Okay. Product. Then price. Customer name, product, and price. Now, can I say that we have 1,000 of data, 1,000 of customers? 1,000 customer. Okay. Now second, same. I will say 1,000 records also. Okay. Third, price. 1,000 price sales. Okay. Now tell me, if I'll go column wise, if I go column wise and trying to compress it, can we do it? What I mean, like there are 1,000 customers record, but there is a possibility that the customer's name, most of the customers' name are similar, right? When I go the column wise, I can say, right? So I can say, if I say distinct, so there are 600 distinct record and 400 are redundant, right? So we can customize, we can compress it to 600 customers because rest 400 are replicated. It's a redundant, so we can compress it to 600 customer, right? Similarly, 1,000 customers are purchasing 1,000 of records. 1,000 customers are purchasing 1,000 of records as products, and but when I say unique products, how many unique products are there? It can be like 100 unique product only, and that can be purchased from multiple customers. So I'll say 100 product unique. I'm telling products. Now price wise, I'm saying there is a lot of chances, like lot of product are having the same price. So I can say let's keep it 100 unique prices we have. Now see, it's compressed. Now 600 customer, 100 products, and 100 unique prices. So data is automatically get compressed. So if you are following a column oriented technique, it help in a compression. Now when I say in a row wise, what is the issue? Row wise I will go like this, right? Row wise I'll go like this. Is that possible that customer name, product, and price will be same and we can compress it? No, that really won't give me an option to compress the data. But when I go with a columnar way, we will get an option to compress it. Is it clear? Is it clear? Any question? Then the last topic is like HBASE table that I will discuss in the next session. But any question as of now? Am I audible? Okay, good. So let's call it a day, and we'll discuss the HBASE in detail in the next session, and I'll share this document to you guys. Thanks.